Hello, everybody, and welcome back to Math 100. Today, we are going to go over practice test number 3, which covers chapters 6, 7, and 8. Okay, so here comes practice test number 3, and I'm going to split this into sets of 5 problems. And so it'll end up with multiple parts, but I hope that would be okay. And so let's look into practice test number 3. All right, here is practice number 3. Practice test number 3, or practice 4, test number 3. It's all the same thing. Look at number 1. The number of cable TV subscribers is increasing by 5,000 a year. All right, and so here's the key: 5,000 a year. Is that a percentage or a Is that a percentage or a fixed number? And the answer is, of course, it's a fixed number. And so that is linear growth. All right, and I'm going to make a little comment here as well. This is linear growth because the growth is by a fixed number, okay, not a fixed percentage, in which if that happens to be a fixed percentage, of course, that would be exponential growth. And then how about the next one? The population of the country is doubling every 50 years. So here, it doesn't specifically say a fixed percentage, but doubling every so many years or doubling every so many periods is a characteristic, distinguishing characteristic of a exponential growth. All right, so the answer here is exponential. And that is true whenever there is a fixed doubling period. All right, so exponential growth because there is a doubling period. You see, if the growth were linear, you would not have a doubling period. And in fact, based on this fact here, based on the fact that it doubles every 50 years, you can do some algebra to figure out what the percentage is for every year. Okay, number 3, suppose that a nonprofit organization is doubling its membership every year. Okay, again, exponential growth. And then there are 6,400 members this year. Now, it's pretty obvious how to do this, I think, right? One, I mean, if you don't know the equation and you don't need the equations, you can go backwards. Right. So the first question: when were there only 200 members? All right. So this is 6,400 6,400 members now. Last year, so it's a year ago, there must have been 3,200 because it says doubling every year. And 2 years ago, that's 1,600. 3 years ago, what is that? That would be 800. 4 years ago, 400. 5 years ago, 200. There you go. So this is 5 years ago, right? And you say, well, I mean, this is such a manual way of doing this. Isn't there a better way of doing this? Yeah, and maybe we can talk about this after we do B. In how many more years would the membership exceed 1 million if this growth continues? And that sounds like a long time, right? So what we can do is we can define or we can come up with a general equation, a formula. What is P sub n? So n in this case is n is 0, meaning now. Okay, so P sub n is, remember, you start with that initial condition. So the question is, how many people do you have now? How many members? And the answer is 6,400, right? And it's growing every year by doubling, right? So you take 2 to the nth power. So P sub 0, of course, that would be 2 to the 0th power is 1. And so, of course, this is 6,400, which is the initial number, the current number. Next year, it'll be 6,400 times 2. The following year, it's going to be 6,400 times 2. The following year, it's going to be 6,400 times 2 squared, right? Every year, it doubles, right? So what we want to do is this. We want to find this number. Remember, this part needs to be done first, is 1 million. Okay, now oops, that is not the correct way to write 1 million. All right, so it's 100, comma 000, right? And so, I mean, technically, in order to solve a problem like this, precisely, you need a method of logarithms, but you don't need to for here, because all you have to do is to just take a wild guess and then make some adjustments, use trial and error. Now, if you know how to do this, using logarithms, that's okay. I am not going to stop you from this. But since this is a course in more of a critical thinking, I would sort of ask that you, make an intelligent guess and then see what happens, right? So you will see, for instance, that if you, okay, so over here, if you do 6,400 times 2 to the 10th, maybe it'll take 10 years, because I mean, that seems like a sort of a reasonable, amount. And then go ahead and do this in your calculator, and you realize this is way too much. Yeah, you will find that, this times 6,400 is 6.5 million. Okay, but that gives you a really nice idea, because 1 year before that would be about 3 million. 2 years before that would be 1.5 million. That's year 8. So the answer should be about 7 or 8. Okay, so let's go ahead and try 6,400 times 2 to the 8th. And you'll find that this is like about 1.6 million, right? Now, that if you plug in 7 here, 6,400 times 2 to the 7th, it'll be exactly half of this, which is 800,000 members, right? So that it's going to be somewhere between 7th and 8th year. So the answer is, of course, you want to take the bigger of the two numbers. You say in 8 years, because 7 years is not quite enough. Okay, 7 years. In 7 years, the number of members will be half of this, which is about 800,000. And so it'll take more than 7 years. And so a safe answer would be 8 years. Now, if you say something like more than 7, less than 8, or 7.5, I would probably give you credit. But within 8 years would be a good way to write your answer. All right, number 4, the population of a small fishing village is growing linearly with the initial population of 800. After 1 year, the population is 1,000. Okay, so this tells you, remember, this is linear. There's a common difference, and the common difference is the difference between these two population numbers, obviously, because this is after 1 year, and so the common difference is 200. Right, so P sub n, if you remember that general formula, is the initial number plus n times 200, right? Because every year you just add 200. After 1 year, you add 200 to 800. After 2 years, you multiply 2 times 200 and 800 is added, and so on. What will the population be after 5 more years? So let's specifically, you are asked to find P sub 6, because 5 more years after P1 would be P6. And so this will be 800 plus 200 times 6. Remember, you have to do this part first, and your answer will be 2,000 people in this not so little fishing village anymore. Okay, number 5, the number of licensed truck drivers in the country in 2010 was 4,000, and it's growing by 3% each. All right, so right off the bat, you can write the formula. Remember the initial value times, how do you describe a 3% increase every year? Well, that's 1.03. This is just like compound interest. This is exponential growth, right? 1.03 to the nth power, if it's growing once every year, that is annual compounding. And of course, that is a model of exponential growth. Write the explicit equation. And so, well, that's good. I just did that, right? So P sub n is 4,000 times 1.03 to the nth power, right? And so it's, since the number n is the number of years since 2010, and that's exactly what I meant by that n. Find the number of licensed truck drivers in the country in 2020. So all you have to do is to find P sub 10, because 2020 happens to be 10 years after 2010. Okay, so 1.03 to the 10th power. Okay, and that's pretty much all you have to do. If you do this calculation, make sure, again, you do this part first, And typically on the calculator, you would do a caret 10, and that's how you find it. Sometimes it's x to the y. And then you multiply this result by 4,000. You will get 5,376 if you round to the nearest whole number. And so the answer is this country will have about 5,376 truck drivers. Okay, so those are the first 5 questions. In the next segment, we will start with section 6, number 6.